Welcome back. So far on the channel, we've covered some of the most popular math topics that you'll see on the SAT and the ACT. But now let's kick things up a notch and talk about some of the most advanced math material that you'll see on the tests. These harder topics might be the key to help you bump a good score to a great score. So if you find this helpful, please hit that like button, share, and subscribe. I do appreciate your support. Thank you. Okay, let's get to some of the hardest math topics that you'll see on the SAT and the ACT. Before we start, I just want to say that this video is going to be a little rapid fire. Usually I'd spend more time on the step-by-step process of solving an equation. This video is meant for the harder topics, so I'm not going to dwell too much on computation. If you need more help with these steps, be sure to check out my math playlist. In those videos, I cover more of the fundamentals of how to isolate a variable. And of course, if you're confused by anything, leave a comment in the section below. Let's start with a topic that's very popular on both tests, the discriminant. Here's how it could come up on a question. If ax squared plus 4x plus 2 has exactly one solution, what is the value of a? I'll help you start this one, and then I'll let you do the second question on your own. Before we get to the heavy lifting, let's just recap the quadratic formula for a moment. The quadratic formula is x equals negative b plus or minus, all under the radical, b squared minus 4ac over 2a. Now, this question deals with a very specific part of that formula, the part under the radical. That portion, b squared minus 4ac, is called a discriminant. And a discriminant tells you a lot about the nature of the roots or the types of solutions that you might get. If a parabola has two real solutions, it means the discriminant is positive. That means you could set b squared minus 4ac greater than 0. If your parabola has one solution, it means your discriminant is 0. You could take b squared minus 4ac and set it equal to 0. And if your parabola has no solutions, it means your discriminant is negative. You can say b squared minus 4ac is less than 0. So let's see how that works on the question we just saw. Let's start by identifying what we mean by a, b, and c. They indicate the coefficients attached to each term. The a is the coefficient with the x squared, the b is the term with the x, and the c is the term without an x. So in this case, a equals a, b would be 4, and c would be 2. And now let's remember what we said a moment ago. They tell us that the parabola has one solution. That means that the discriminant equals 0. So we could take b squared minus 4ac and set it equal to 0. And from there, just plug in the values for a, b, and c. Plugging in those numbers would give us 4 squared minus 4 times a times 2 equals 0. From there, solving, 16 minus 8a equals 0, 16 equals 8a, so a would equal 2. So, if they tell you that a parabola has one solution, it's just a complicated way of saying to set the discriminant equal to 0. Let's try another. If the parabola x squared minus 6x plus c has no solutions, which of the following is a possible value of c? I'll give you a minute. Press pause, give it a try. So let's start by identifying the a, the b, and the c terms. The a is attached to the x squared. In this case, it would be 1. And the b would be 6, and the c would be c. Now the key phrase here is that they say no solutions. What does that mean? It means our discriminant is negative. So we are allowed to set up the equation b squared minus 4ac is less than 0. Less than 0 means negative. And then from there, we could sub in the values that we have. 6 squared minus 4 times 1 times c is less than 0, which would give us 36 minus 4c is less than 0. Combining like terms and solving, we would get 9 is less than c. So if 9 is less than c, it means c has to be greater than 9. The only answer here that would work would be D. The answer is D. So when they tell you something about the nature of the roots, it's often a clue that has something to do with the discriminant. So one more time, two solutions means your discriminant is positive, one solution means that your discriminant is 0, and no solutions means your discriminant is negative. And I know what you're thinking. No, this will never be relevant in life, but the tests want you to know it, so here we are. Another popular topic on each test is how to rationalize a complex fraction. Let's look at one. Simplify the expression 5 plus 3i over 7 minus 4i. Before we start, let's talk about what that little I means in the world of math. A little I stands for imaginary. It means the square root of -1. It's not possible to take the square root of a negative number. You can't multiply anything by itself to get a negative answer. That's why we call it imaginary. So let's see how that works on this question. To simplify a fraction like this, you have to multiply the top and the bottom by the conjugate of the denominator. What? I'll explain. An imaginary number always appears as something like a plus bi, but that will always have a partner, a minus bi. You just switch the sign of the second term. Those are called conjugate pairs. So why is this important? Something very special happens when you multiply a complex number by its conjugate. Let's check it out. Again, we're going to start by multiplying the top and the bottom by the conjugate of the denominator. So the conjugate of the denominator would be 7 plus 4i. We're going to multiply that to both the top and the bottom. And if we were to work that through, in the numerator, you would end up getting 35 plus 41i plus 12i squared. But let's take our time with the denominator. Multiplying 7 minus 4i times 7 plus 4i, let's go through FOIL, or the box method, as some of my students call it. But either way, 7 times 7 would give us 49. That's 7 times the 4i, positive 28i, the negative 4i and the 7, negative 28i, and then the last terms, negative 16i squared. And look at what happens. Those outer and inner terms, the 28i and the negative 28i, will cancel out. So in our denominator, we're left with 49 minus 16i squared. So here's where things get interesting. Remember what we said before. I represents the square root of negative 1. So if we squared that, that would give us I squared is negative 1. Squaring just gets rid of the radical. And now wherever we see an I squared in that expression, we could just substitute in negative 1. Plugging that in and combining like terms, we would get in our numerator 23 plus 41i, and then in the denominator 65. That's the final answer. And that's why it's so helpful to multiply a complex number by its conjugate. When you go through FOIL, the outer and the inner terms will always cancel, and the last term you can sub in a negative 1, so it will become an integer. The numerator still has the imaginary number, but the denominator doesn't. Let's just look at one more. What would you do to simplify this complex fraction? You would multiply the top and bottom by 3 minus 5i. And don't worry, I won't drag you through the math again. But if you went through it, you would see that the denominator would no longer be imaginary. It would become a regular integer. Now let's look at reference triangles. These have been a favorite of the ACT for years, but they recently started popping up on the SAT as well. Let's try one. If 3 pi over 2 is less than theta, which is less than 2 pi, and the tangent of theta is negative 5 over 12, what is the value of the sine of theta? Before we start the heavy lifting, let's just talk about radians for a moment and reference triangles. 1 pi radian is a very complicated way of saying 180 degrees, and from there they want you to sketch a triangle in the coordinate plane. So in the coordinate plane, you can call quadrant 1 0 to 90 degrees, but 90 is really pi over 2. And then to go to the end of quadrant 2, that would be 180 degrees, or pi, and so on. 270 could be called 3 pi over 2, and then 2 pi is really 360. That's how they want you to label the degree measurement in each quadrant, if they're doing it in radians. And from there, you draw a triangle in each quadrant. A lot of my students like to call this the bow tie method. Looks like a little bow tie. Notice, you always connect your triangle to the x-axis, never to the y-axis. So look at the location of that theta, the little angle symbol, not to the y-axis, always to the x-axis. And from there, be very careful whether or not the legs of the triangle are positive or negative. So, for example, let's look at quadrant 2 in the top left. Notice how we're going to the left. That makes the x value negative, and then we're going up, so the y value is positive, and so on in each quadrant. And no matter where you are, the hypotenuse is always a positive number. So that's a bit of a crash course in radians and reference triangles. So how does all of that relate to this question? Well, they tell us that the theta is between 3 pi over 2 and 2 pi, or 270 to 360. That means we're going to be in the fourth quadrant. So of all of the triangles in this picture, we'll just be working with the one in the bottom right. So let's just focus on that triangle. We can draw our reference triangle in the fourth quadrant, and notice where the theta is now, connected to the x-axis. And since they told us that the tangent of the theta was negative 5 over 12, remember the ratio for tangent, SOHCA TOA, opposite over adjacent, the opposite would be the negative 5, and the adjacent would be the 12. And it's very important that the 5 is the negative and not the 12. Why? Well, we're in the fourth quadrant, so in the fourth quadrant, going to the right means your x value is positive, the positive 12, and the y value going down is negative. That's why the 5 is negative and the 12 is positive. And now they're asking for the sign of the angle. How do we find sine? Well, let's go back to the mnemonic device, so kotoa. So, SOH, sine of an angle, is the opposite over its hypotenuse. So we know the opposite is the negative 5. And now we need the hypotenuse. How can we find that? Well, it's a right triangle, so Pythagorean theorem would be fine. But you might have spotted here, there's a Pythagorean triplet going on. Two triplets worth knowing are 3, 4, 5, and the other one, 5, 12, 13. If we have a 5 and a 12, that hypotenuse must be a 13. And from there, they just want the sign of the angle. So opposite over hypotenuse would be negative 5 over 13. That's the answer. So reference triangles have a lot going on. So just to recap that one more time, you first have to determine which quadrant to draw the triangle in. From there, be sure to connect it to the x-axis and be super careful which legs are positive versus negative. And then from there, it's usually a whole lot of SOHCAHTOA to find the missing sides. And you could always do Pythagorean theorem, but they do like to slip in triplets or special triangles. So be on the lookout for those. Now, all of that was some very advanced math, so if you are totally stumped by everything I just said, that's fine. Check out my video 16 here. In that video, I talk about a great test-taking trick when dealing with reference triangles. It will help you avoid a lot of the math that we just saw. Another popular topic is converting units. Let's start with an easy one, and then we'll see a harder variation. On a map, 1/2 inch represents 3.2 miles. What distance is indicated by 6 inches on the map? Well, they're giving us a ratio, inches to miles. So we could set that up as a proportion. Inches to miles equals inches to miles. Or in this case, 1/2 inch to 3.2 miles equals 6 inches over x miles. Cross-multiplying to solve, you would get x equals 38.4. So when they give you a part-to-part ratio, you could set it up as a proportion. But now let's make things a little harder. At its fastest speed, a roller coaster travels 792 inches per second. How fast is it going in miles per hour? So we're going to be converting inches per second to miles per hour. And in order to do that, we need to get certain units to cancel. Let's see how. So let's start by writing this as a fraction. 792 inches over 1 second. Now from there, the idea is to get certain units to cancel. So let's think about how we could get from seconds to hours. Well, 60 seconds in a minute, and 60 minutes in an hour, so 60 times 60 would be 3,600 seconds per hour. So we can multiply that by 3,600 seconds over 1 hour. And there's a reason we're putting the seconds in the numerator. It's so that the seconds will ultimately cancel. And then from there, we could work on converting between inches and feet. Well, 1 foot is 12 inches, so we could multiply that further by 1 foot over 12 inches. And same thing. We want to put the inches in the denominator so that it'll cancel with the inches in that first fraction. And now we could use that piece of information they tell us that 1 mile is 5,280 feet. We could multiply that by miles over feet. And same speech, we're putting the feet in the denominator so that they cancel with the feet in that third fraction. And now watch what happens if we multiply. The inches in the numerator of the first fraction will cancel with the inches in the denominator of the third fraction. Likewise, the seconds in the denominator of the first fraction will cancel with the seconds in the numerator of the second fraction. And then same thing with the foot and the feet in the third and the fourth fractions. And then just multiplying the numbers, you would get 45 over 1. 45 miles over 1 hours. And with all of those units canceling, we are left with miles per hour. And the name for this is called stoichiometry. What? Don't worry about it. But simply put, always try to convert so that units will cancel. So try to set up the fraction with the same term in the numerator and then the denominator. That way, they'll disappear. That was a little challenging, so let's try it on one more question. The speed of light is approximately 300,000 kilometers per second. What is the speed in miles per hour? I'll give you a minute. Press pause, give it a shot. So let's see if we could set this up to make the kilometers disappear. Well, if we write it as a fraction, 300,000 kilometers over 1 second times 1 mile over 1.609 kilometers. We're putting the kilometers in the denominator so that they cancel with that first fraction. And then likewise, times 3,600 seconds over 1 hour. That way the seconds will also cancel. So we will be left with miles per hour. multiplying through would give us 671 million. Long number, long number, long number. Who cares? It doesn't matter. The point being, by setting up the fractions this way, we were able to cancel kilometers with kilometers and seconds with seconds, so we are only left with miles per hour. So these are some of the most challenging topics that you'll see on the SAT and the ACT, and this might be where those last few elusive points are found. If you want more help on some of the most challenging topics, check out my video 30 here. In that video, I cover some of the most challenging math material that's specific to the ACT. And be sure to go through my math playlist as well. There's some other great videos there too, ranging from the fundamentals, like isolating a variable, to the most advanced math, like how to multiply a matrix. So there's something there for everyone. Thanks for watching. And remember, plan your work, work your plan.